In this video, we're going to derive the derivative of cosecant of x using the quotient rule. Now first off, remember, cosecant of x is 1 over sine of x, and that's what we're going to use to help us get this derivative. And the domain of p is all reals except for places where sine is 0. So x cannot equal integer multiples of pi. So n is an integer, because that will make sine 0, and then we'll be dividing by 0, which we know causes a problem. So first, let's use the quotient rule to find p prime of x in terms of sine and cosine, and then we'll see if we can rewrite it in terms of cosecant and cotangent. So our quotient rule: denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So let's see what happens. Derivative of 1 we know is just 0, so we end up with sine of x times 0 minus 1. The derivative of sine of x is cosine of x all over sine squared of x. So let's simplify this a step. Sine of x times 0 is, of course, just 0. Minus 1 times cosine of x gives us a negative cosine of x over sine squared of x. Now, that would be it in terms of sine and cosine, but let's say we wanted to write it in terms of cosecant and cotangent. What we could do is we could split off. We have a negative 1 over sine x times cosine x over sine x. And what we see is this 1 over sine x, well, we know that's cosecant, and it's negative, so cosecant x, and cosine over sine is cotangent. So this is the more common way we'll see the derivative of cosecant written. But it could be, this is fine in terms of cosine and sine. It depends on what you want to do with it. Lastly, the domain of p prime, well, it's the same as the domain of p, because once again the big issue is that sine is in the denominator. Can't have any x value that makes sine 0, so we need to exclude all the integer multiples of pi.